So this lesson is about taking that scale factor that we've learned in the previous lessons on reducing a figure or enlarging a figure using that scale factor. We're actually going to learn how to draw them so that we draw them in proportion, and it's just that scale factor either with us reducing it or enlarging a figure. So there's two different methods. One that we can look at, and we'll look at it and use it for reducing, so making a shape smaller. And then I will show you a second method where we can use it to enlarge a picture. So we've got options. So we use this first one, it's called the ratio method. So kind of in that same aspect of we're just going to, since we're reducing, we're going to shrink the size of this shape. And by doing that, then we need to know what that scale factor, which that scale factor, if we're going to be reducing, means that scale factor is going to be less than 1. So we'll take that factor, that scale factor, and then multiply our side lengths by it to figure out what our new side lengths are going to be. So in order to do that process, we can have this lovely shape. We might have a pentagon like what we've got going on here. And the first task that you need to do is just pick a point, draw a point that's not on the shape. It can be away. They could say it can be external. So pick a point anywhere away from that shape. And that's going to basically become the center of reducing this shape. So now what your task is to do is you will draw lines from this point to each of your vertices of your shape that you've got. So you're essentially drawing all these lovely points that converge back onto your shape. So drawing everything back to your point that you've picked. And once we're done with that, then we will go on to the next step. So every single one of these, we draw right to that point. So now what you end up doing, we can go to step 2, and what I'll do on the next page is show you the process of what we do to get to the next piece. So again, I can pick a point someplace out here, and that process again, doesn't matter how far out you go with it. You just got to make sure that you end up drawing all your points from your vertices back to that main point. So I'm going to draw everything into that main point. And then, some of my lines are really tightly close together. So I'm wondering if it would be of value to move your point. We moved it out here. Things to play around with, right? You get to experiment with that. Okay, so now the idea here is, say we use, let's take our scale factor and we're cutting it by 1/2. So that's like saying whatever distance I have, I'm going to times it by 0.5, right? So whatever line segment I have, I'm going to times it by 0.5 to find basically what that scale factor is. So each of these lines that we have drawn to get us to our vertices, now I have to take, because it's a scale factor of 0.5, if it was a scale factor of 1/3, I take 1 divided by 3 and I get 0.333. I'd times my side lengths all by 0.33 and figure out what that distance is. So for instance, if I take and find, I want to find the length from this point here all the way back to my point here, which looks like it's about 3.6 for the total distance from here to here. Well, I want half of that, 3.6, which would make it, what, 1.8. So that means I'm going to come back and place a dot at about 1.8, someplace in here. That's where I'm going to place a dot. That's the vertice, the beginning vertice of my new, getting quite the glare here, aren't I? For my new shape, that's the beginning of it. So now I'm going to take this from this distance to here, which if I measure again from my point to that distance, it looks like I'm looking at 2.2. So half of 2.2 would be 1.1. So I'm going to have a point that goes here. So essentially, I'm drawing all the points from the distances halfway from each of these distances, these lines going out, which means I've got 1, 2, 3, 4, 5 lines. So I'm going to end up with 5 points that I'm going to end up connecting the dots to, and that's going to create my new shape. So now I'm going to take and find this distance. I'm going from here down to down here, which looks like 4.3, and half of that, it was half of 4.2. Oh, it's so close in there. So I'm looking at 2.1 maybe, and a little bit. So someplace, hey, I'm hitting right on my, almost right on my line there, right? So I place the second dot there. So now you're starting to see if I connect here to here and here to here. Now, if I used a straight line actually and did that, I would have it looking a little bit better. So I go straight to there, and it's like connecting the dots. So I'm going to go straight to there. Now I'm moving over to this line over here. What is that distance? All the way to my dot. So here I am looking at roughly 3, which would be 1.5. So I'm going to go there. And then I'm going to go with the last one, which I'm going, looks like maybe 2.2, someplace in there might be 1.1 and a little bit. So I go right in there someplace. So now I can continue connecting all my dots. So I could go here to there, and then I can go there to there, and then I'll connect across here. And what I end up creating, or what I should have created, is a reduced shape of what I've got going on here. So it's the exact same shape, but it's just reduced in size. So that's how you do a reduction using that ratio method. You're drawing a point outside of your figure, and you know it's moving away from your original shape. It's going to get smaller and smaller as it moves out and out. Now what I'm going to show you is if we want to enlarge something, make it bigger, if we're going to enlarge something, we can use something what we call the parallel method. So in this instance now, it's kind of like almost the reverse of what we're doing. We're going to pick a point inside our shape, and then we're going to draw our distances to our vertices, just like so. And then from there, once we know that distance, once we know what scale factor we're doing, we'll take this distance that we're drawing here and then multiply it by whatever our scale factor, which is going to push our distances, our lengths, way out further, which is going to create our same shape, but it's just going to be bigger. It's going to be out beyond. So that's going to be the same kind of sense in what we're doing here. So if we start this again, let's pick a point. Doesn't matter where, pick a point inside your shape. And again, we are going to take our ruler and we are going to draw from each vertice. We're going to draw lines right to our point that we created in the middle. So we'll take that, draw it, and draw out to the edge. Okay, so now we've kind of created those. We've got 4 vertices, our 4 corners, which means we have 4 lines that we're going to end up. And in this sense too, what I should have done with these is, you know what we could do is draw them out further if we want. Draw them, extend them out so that we have that proper angle coming off of that. So we connect those dots, but we extend that line beyond, because what that will help us do, we're going to have to measure from each of these, from that vertice in the center, our center point, measure out once we know what our enlargement is going to be, what our scale factor is. So we want an enlargement this time where we're going to double the size of the shape, which means we're going to times everything by 2. That's what we're going to end up doing. So what we want to do now is we essentially, on each one of these, we're going to measure from the center right to our to the vertice, right out to the edge. So center, someplace in there. And it looks like I've got 1.8. So if I know this is 1.8 in here, this distance is 1.8, but I want to take 1.8 and times it by 2, which is going to give me 3.6. So that means from the center of where I put that point, I'm going to come over 3.5, 3.6. And that is where I'm going to place a new point. So that's going to be a new point on my enlargement. And now I'm going to go around and do that for every single point that I have. So in this case, I'm looking at this and it looks like I'm at maybe 1.6. So I times 1.6 by 2 and I'm going to get 3.2. So that means if I'm going 3.2, that's going to bring me, there's 3, 1, 2 right there. So I'm going to place the second point there. And so what I'm going to end up doing is I'm going to get a shape that starts to evolve here. We're starting to create what this is going to look like, right? So I am going to, the ruler's too long. Okay, hang on. I'm going to turn this just a little so I can see this. So now I've got a distance of 2, but I want to take that 2 and I'm going to multiply it by 2, which is going to get me to 4. So I'm going to have a point out here. So now as I go, I keep connecting my dots together and I'm starting to get the beginnings. Hey, look at that. You've got that angular piece. Here I've got this slightly shifted piece as well starting to happen. So now my last piece, I'm going to measure from the center right to my vertice. It looks like I might be 1.3, or oh no, this is 5, 6, 7, 8, 1.8. So same thing, 1.8. I'm going to 3.6, which is going to get me about there. Again, put that point. And so now what I can end up doing is I'm going to draw and connect my dots and then connect back to my original one down here that I started with. And what I've just created is my enlargement of my original shape. So that's using the parallel method to do that one. So when I'm enlarging, I'm putting my point within my shape, and then I'm building outwards. With the ratio method, I'm putting my point outside, and then I'm kind of creating that shape that's smaller. So now that is how you enlarge, how you draw an enlargement and a reduction. Now you can go work on a practice.